Ladies and gentlemen, welcome to Dr. Doctor, the show where no topic is too hot or too cold. Whether it's politics, religion, relationships, entertainment, or everyday life, you will be hearing from the experts. This show is not for the faint of heart or the faint of mind. But if you want to be inspired, you have come to the right place. And now, prepare to be enlightened as we introduce the host of Dr. Doctor, Dr. Peter Tassi, and his close advisor, Dr. Fooch.
Welcome again to Dr. Doctor. Hoping that you're having a great day and you've had a great week. And we welcome you back to Dr. Doctor. Today, we're going to give you a very boring topic. Hopefully, it's stimulating to some of you and interesting and informative and educative. But to many, it may be boring. Just tune us out. No problem. Today, we're going to look at the history of time. And as I mentioned in previous podcasts, if you'd like a copy of this digitally, you just have to email us at drdoctorpodcast@yahoo.com. And we'd be happy to send you a copy of the history of time. But today we're going to go through it, and we're going to look at the history of time since the beginning. Some describe it as the Big Bang, right? The beginning of the universe, as far as we know. When did it start? All the way up to present day. And we're going to do this in two parts. So we'll start today with roughly 14 billion years ago when the universe started, and we will end probably around 30,000 years ago. And what we hope to accomplish in this two-part series, The History of Time, is not only informing you and giving you some idea of what a lot of the scholars say, how time has evolved since the beginning of the universe, but to realize through this that when you suspend yourself from your present situation and look down on this history, almost like you're overlooking the entire history of time, that you see that we really are all brothers and sisters of the same family. We're all one. We're all one human family on earth. And this, of course, leads us to the conviction or belief that we really have an obligation to love each other and to help each other just as we do our own brothers and sisters. Sometimes our love is misguided, and we think we're helping other people or other nations, and we're not. So, but anyway, that's a topic for other discussions on the podcast. But let's start now, 13.7 billion years ago to 12 billion years ago. Here we go. I hope I don't bore you too much, and I hope you find it informative and educative. We'll go through it quickly. 13.7 billion years ago to 12 billion years ago. The universe begins with what we often call the Big Bang. A tiny bundle of energy, smaller than an atom, creates all the energy that will exist. The universe then inflated over the next 13.7 billion years to what we have today. This theory is based on mathematical formulas and models. Then came the eventual creation of atoms and hydrogen. Atoms blast through the universe, forming galaxies. Clouds of gas and dust squeeze together because of gravity. Temperatures rise to 18 million degrees Fahrenheit. Hydrogen atoms slam together and create helium, radiating bursts of energy. There is a burst of stars that are formed. 12 billion years ago to 5 billion years ago. The first galaxies begin to form along with the stars. Stars fuse hydrogen into helium, helium into lithium, creating 25 common elements such as oxygen, carbon, nitrogen, and iron. Stars explode, called supernovas, creating energy to make copper, uranium, gold, and all the elements that shape our world. Stars continue to explode and are reborn with the more heavy elements than previously mentioned. About 5 billion years ago, a new galaxy forms, the Milky Way, along with our Sun. So 5 billion years ago to 4.5 billion years ago, our star gathers up 99.9% of gas and dust in our solar system. Enough gas and dust remain to build planets. Earth forms with gravity pulling Earth and rock together, along with other planets that circle the sun. Earth is a ball of fire, 2,000 degrees Fahrenheit, with no air and only carbon dioxide, nitrogen, and water vapor. There is little oxygen, if any at all. The Earth is spinning fast, a full day only lasting 6 hours. A planet the size of Mars smashes into Earth, traveling 25,000 miles an hour. Earth swallows it and releases molten debris into space, creating our moon. The moon exists roughly 14,000 miles from Earth. 4.5 billion years ago to 4 billion years ago, our sun settles down. Planets and asteroids orbiting the sun. The moon keeps Earth steady, preventing it from wobbling and creating wild climate swings. Moon's gravity also slows Earth's rotation, creating longer days. Lighter materials drift to Earth's surface and create a crust with heavy materials sinking to the center. These materials form molten iron and nickel. This creates a magnetic field reaching out to space and protecting Earth from the sun's deadly rays. The Earth's surface is a turmoil of rock and water. It is still too hot for liquid water, but there is steam and water vapor in the atmosphere. 4 billion years ago to 3.8 billion years ago, rain falls, the planet starts to cool, forming oceans and lakes. A hail of meteors hit Earth. There are crystals inside meteors that contain water. Meteors also carry minerals, carbon, and primitive proteins that go to the bottom of the now existing oceans on Earth. The ocean starts spewing out hot liquid containing minerals and gases. 6 elements combine in the ocean to form the substance of life. DNA and bacteria are now forming. We have single-cell life. Earth's surface forms a stronger crust, and the moon gradually moves away from the Earth, causing the Earth to spin even more slowly. Tiny islands form from lava rock and volcanoes. Islands come together to form land masses. 3.8 billion years ago to 2.5 billion years ago. Bacteria have figured out how to consume the sun's energy. They create a waste product called oxygen. Plants form on the ocean floor, turning sunlight into food. Sunlight also turns carbon dioxide and water into sugar, glucose. Bacteria learn to live on this oxygen and become 20 times stronger. Life now exists on Earth in the form of a single-celled organism, bacteria and microbes, living with or without oxygen. Some may have been fed by methane. The massive amount of oxygen being released turns into rust that forms iron-rich rock, which rises billions of years later to give us iron and steel. Viruses may also have been present at this time. 2.5 billion years ago to 2 billion years ago. This period is described as the Great Oxidation Event. One theory is that oxygen starts to build up in the atmosphere. Oxygen continues to make the iron in the oceans and into rust and sink to the bottom. Likely as a result of a lack of volcanic activity during this period, the Earth freezes over. But when the ice begins to melt, it results in more oxygen being released into the atmosphere. We see signs of photosynthesis, the ability to take in sunlight and carbon dioxide, obtaining energy, and then releasing oxygen as a byproduct. 2 billion years ago to 1 billion years ago, single-celled organisms are becoming more complex. The sky and water are blue. Earth plates move, forming more land masses. Continents form. Oxygen levels rise to 13%, and the day is now 18 hours long. Genes of single cells combine, and we now have 2 cells and 2 sets of genes. This can be considered the beginning of sex. Cells with internal organs known as organelles come into being. Genes are stored in the form of DNA in the nucleus of the cell. 1 billion years ago to 750 million years ago, multicellular life begins to develop. Single-cell creatures form colonies consisting of many individuals. Early multicellular animals undergo their first splits. Over 20 million years, thin plate-like creatures form, and about 1 millimeter across, with only 3 layers of cells. These may be the ancestors of animals. Certain cell lines went on to evolve into green algae and plants. Cells evolve in many different directions. Sponges and jellyfish are now in the seas, later joined by shrimps and lobsters. 750 million years ago to 650 million years ago. Heat escapes the molten core and splits continents in two. Biology explodes, bringing about bigger and more complex organisms that rely on water and oxygen flowing through their bodies. Volcanoes are pumping carbon dioxide into the air that mixes with rain, creating acid rain. Rocks absorb the carbon dioxide and acid, taking it out of the atmosphere. Earth's temperature plummets, creating another ice age. The ice deflects the sun's rays and the planet grows colder. Although the entire planet is covered in ice, its core is hotter than the sun. Volcanoes continue to pump out carbon dioxide until it seals the earth and causes temperatures to rise. The ice begins to melt. There is a great deal of water, and the days are now 22 hours long. Throughout history, we see how volcanoes have caused global warming or ice ages. Many factors are involved in these patterns. Oxygen levels now rise because of the production and breaking down of hydrogen peroxide. 650 million years ago to 500 million years ago. Some sea animals evolve bilateral symmetry, having defined top and bottom as well as a front and back. These creatures are believed to be like a worm. They eventually split into two groups, those that include a vertebrate and those that become insects, spiders, shrimp, and the like. Males and females are created from these in the ocean, and they form skeletons and have spines, jaws, and teeth. The sun's rays meets the Earth's oxygen and form the ozone layer, 30 miles above the Earth, protecting Earth from the sun's radiation. Plants begin to grow on land. Skin cells mutate and develop eyes so that the ocean's creatures are no longer blind and can see food and danger. Nerve cells develop behind the eyes that go to the brain so they can now make sense of the things that they see. 500 million years ago to 400 million years ago. Plants begin to colonize the land. Many new plants and animals are forming. Animals start exploring the land. More splits occur, with some sea creatures having skeletons made of cartilage rather than the harder bone. These eventually include all the sharks. Lobe fish Lobe-finned fish later become amphibians, reptiles, birds, and mammals. Large ocean creatures now exist. Ray-finned fish give rise to most of the fish species we have today. Lungfish break from the lobe-finned fish and develop a pair of sophisticated lungs divided into smaller air sacs. This allows them to breathe out of water and survive when ponds dry out. We have amphibians capable of living on land and in water. Insects can live their full life outside of the water, and they learn to master flight. 400 million years ago to 300 million years ago, massive ocean creatures eat small fish, so they move to shallow water with less oxygen. To stay alive, these small fish start to move to the surface of the water and breathe through their this new organ that has developed, the lung. Their fins grow and serve as small legs or limbs to move out of the water and onto the land. They begin to lay their eggs on land. These eggs have a hard shell that contains some ocean water. Four-legged animals evolve in shallow freshwater habitats. These animals also move on to conquer the land and give rise to all amphibians, reptiles, birds, and mammals. These amphibians make land their home. They evolve into reptiles, cutting ties with the ocean. They develop tougher skin and claws to adapt to the hot earth floor. Males find it difficult to fertilize through the tough cells, so they begin to have sex before eggs are laid. Lizard brains evolve and they become large meat-eating creatures. They now dominate the land. 300 million years ago to 250 million years ago. Life flourishes in the marshes. Plants are growing and dying and are being packed into the ground, eventually forming coal. Reptiles are evolving and adapting. Dragonflies form along with larger insects and spiders. The entire land surface of Earth emerges into a single continent, only to split 50 million years later. There are streams, forests, and massive exotic creatures. Earth is paradise until volcanic activities cause carbon dioxide to fill the atmosphere once again. This causes the Permian extinction, where 90% of all species on Earth go extinct from the heat of Earth, from volcanic ash, sulfuric acid, and so at this time in history, roughly 250 million years ago, almost everything on Earth dies. 250 million years ago to 200 million years ago, small cat-sized creatures that had taken to living underground to survive venture out of hiding. The Earth begins to heal. The ecosystem recovers. Then the dinosaurs evolve from the few species of crocodiles and lizards that did survive. The dinosaurs take over, ruling the Earth from 245 million years ago until 65 million years ago. Early dinosaurs are evolving into birds. Small creatures the size of rats and small cats have burrowed back into the ground to escape the dinosaurs. They develop powerful senses and brains. They start to give live birth and feed newborns with milk. Over 4,000 of these small species evolve. Several types of reptiles colonize the sea, becoming large marine reptiles. Mammals survive as small nocturnal creatures. Forests take form, and the moon's gravity settles the Earth into what we have today, a 24-hour day. 200 million years ago to 100 million years ago. Land masses break apart and new oceans form in between. Small animals fight to survive dinosaurs, some growing fins and moving back into the ocean. Dead fish and plankton on the ocean floor become oil. More lands break apart, including America and Africa. A group of mammals that had given birth to live young begin to lay eggs. Mammals continue to break off into different groups: hoofed animals, whales and dogs, primates, rodents and others, anteaters and armadillos, elephants, aardvarks and others. Flowering plants emerged about 130 million years ago. 100 million years ago to 65 million years ago. The dinosaurs reach their peak in size. The oceans become starved of oxygen, perhaps because of a huge underwater volcanic eruption. 27% of marine invertebrates are wiped out. The ancestors of modern primates split from their ancestors of rats. These rodents go on to be successful, making up 40% of the modern mammal species. Grasses evolve and vast grasslands form. Dinosaurs begin to die off about 65 million years ago. We're unsure as to why this happens, but it did. There's different theories concerning that. Mammals continue to evolve into many forms. 65 million years ago to 25 million years ago. 6-mile-wide asteroids hit the Earth, creating a deadly vapor that surrounds our planet. Temperatures drop, and every animal on land over 50 pounds perishes. Even the plants died. This spells the end of the dinosaurs. There's one theory. A 6-inch long mammal that had lived underground manages to survive. Eventually, as the Earth warms, they come to Earth's surface and take to the trees to eat fruit. These become the first primates, with their tails shrinking, forming a coccyx, and arms getting longer and more flexible. These 6-inch long mammals eventually evolve into monkeys. Mammals are growing in variety and complexity. Massive creatures evolve once again. Some monkeys branch off to become higher primates. With this slow warming, mammal ancestors are evolving with bigger eyes and bigger brains. You see how we're getting close here. It's evolving. 25 million years ago to 10 million years ago. With continued global warming, hundreds of species scatter in every direction. We have the hominid primates that are primate chimps in Africa. Primates are the root of our human family. It is an ape-like species. They are in Africa, Asia, and Europe. Primates continue to live in trees and eat fruit. They occasionally walk on the branches in order to reach for food. They build nests in trees to sleep in at night. Long sleep sessions allow for mental development, and they seem to develop empathy and sympathy. Females never leave the group, caring for the young. They become very resourceful and sometimes are the leaders of a group. Their formal language is to groom each other and share food. They adopt laughing as a means of resolving tension. They discover the first tool, a slim stick used to retrieve termites out of dead wood. The Earth begins to look like we know it today. 10 million years ago to 4.5 million years ago. Our primates continue to evolve, still living in trees but standing more and more on 2 legs. They slowly evolve to the point of just walking. Grass grows abundantly, leaving fewer trees and more grasslands. Primates now start to leave the trees for longer periods of time. As resourceful as the females are raising their children, the males become dominant once again. Primates begin to feel desire for each other and start to court each other. Forms of kissing begins. They still move on all fours, but there is a gradual move to be upright, with hands slightly off the ground. Some of these primates are evolved to the point that we call them hominids. The earliest known partially human-like hominid exists in Ethiopia 4.4 million years ago. Ardipithecus. 4.5 million years ago to 3 million years ago. Changes occur in the primate's skull, spine, and legs. They are now bipedal and have bigger brains, the size of an orange. They finally abandon living in the trees. They are about 4 feet tall and weigh about 80 pounds. They set out to find more supplies of food on land. They become more and more upright as they reach for fruit, look out over the tall grasslands, and in order to get less sun on their bodies and to cool themselves more efficiently. They save energy by walking upright. From the waist down, they look like us, but from the waist up, they are apes. Some will still take to the trees to sleep safely at night. These become the early hominids. Lucy is discovered and dated 3.2 million years ago. Many of you are probably familiar with Lucy. And termed the Australopithecus. 3.5 million years ago to 2.5 million years ago, we have the Australopithecus hominids. They begin to outthink their predators. Their brain is now the size of a grapefruit. They have weaker jaw muscles, with teeth getting smaller and the brain growing larger. They eventually evolve into the Homo habilis. Homo habilis use a tool considered by some to be the first tool, a rock, as an instrument to attack and cut. They slowly develop longer and stronger thumbs. This gives them the nickname handyman. They stand almost upright, their teeth getting smaller, and their brain growing slowly in size. These Homo habilis are the first members of the Homo species and are Homo sapiens' oldest ancestors. This first human is discovered in East and South Africa. Although they still have many ape-like features such as long arms, they are slowly evolving into a smarter, more human-like species. The use of these unpolished chipstone tools marks the beginning of the Stone Age, 2.6 million years ago. The Homo habilis evolved until 1.4 million years ago. Then they become what's called Homo erectus. 2.5 million years ago to 1.7 million years ago. Hominids continue to walk the land, breaking rocks to make them sharp tools. There are over 20 species of hominids, but most become extinct. They have larger brains, smaller teeth, and are totally bipedal now. Homo habilis, with the larger brain size, learns to control fire in early stages of cooking meat. They stand 5 feet tall and erect. They have very primitive sounds that can account for the beginning of language. They are descendants of the first developer of primitive stone tools. The ape-man Homo habilis continues to evolve into the Homo erectus in East Africa. They are the first ancestors of modern man. Homo erectus evolved roughly 1.8 million years ago. They have human-like body proportions. They move out of East Africa into Europe and Asia. They master the use of fire and cook their food. Their brains continue to grow, and they use tools, technology, and culture to work together, hunting and gathering food. They begin to include shellfish and other marine sources in their food supply. They exist until roughly 145,000 years ago, evolving into Homo sapiens. 1.7 million years ago to 800,000 years ago. Homo erectus, now completely upright, are hunters in Africa, China, and Indonesia. They are the oldest known early humans with human-like bodies. They use sharp stones and hand axes to carve out carcasses. This requires less energy for chewing and digesting food, and provides more energy for their brain. They gradually become taller and slimmer and start to communicate with primitive words, beginning to use elementary speech and language. They care for their old and the weak. They work together to successfully hunt animals with stone tools and weapons. With longer legs, low shoulders, strong buttocks, and the ability to sweat, they can run long distances. They gather around their dead to mourn their loss. Language becomes more advanced. They are found in Africa, Asia, and Europe. This brings us now to 800,000 years ago to 250,000 years ago. We're getting close. We're getting closer and closer to today. So 800,000 years ago to 250,000 years ago, Homo erectus, our early and primitive Homo sapien, used fire, cooking their food, and using less and less energy to chew and digest. They consume massive amount of calories now, giving them more energy, and their brain grows by 50%. Communication evolves and forms the basis for a developed language. Towards the 250,000 years ago, these early humans begin to communicate with symbols using chunks of pigment. Tools are becoming more advanced. 250,000 years ago to 100,000 years ago. This period is considered the origin of the Homo sapiens in Africa. They are considered modern humans. Their tongue changes shape and their larynx and voice box drop, allowing them to develop more complex communication and networks. They spread out to other continents. Some break away and become Neanderthal men, having great strength and capable of enduring extreme cold. The cleverest of these species survive, while others become extinct. The second migration from Africa begins about 150,000 years ago. The Neanderthal become well established in Europe and Asia. Some 100,000 years ago, we see them acting more like humans, living in large groups, mating with other groups, and communicating ideas. Modern man and the Neanderthal coexist and breed with each other in Europe and Asia until roughly 35,000 years ago. 100,000 years ago to 70,000 years ago. Now fully human, Homo sapiens control fire, use primitive tools, have agile hands, are inventive, live in complex societies, and develop a strong imagination. They are now spread throughout the world, especially Asia, where climate and diet changes the way cultures look. Neanderthal exists in large numbers but become less and less of a force, their numbers eventually beginning to decline. The human species is becoming more modern. About 75,000 years ago, a super volcanic erupts, blackening the skies with ash and placing us in another ice age, killing off many people. Some argue it was the closest we came to human extinction. In addition to killing many humans, many of the larger creatures died off. Some of these include saber-toothed cats, woolly mammoths, rhinos, ground sloths, and giant beavers. There are roughly 30,000 humans alive in the world at this time. 70,000 years ago to 30,000 years ago, the climate continues to change. The ice age causes the death of many. Sea levels fall and small groups of Homo sapiens continue to leave Africa for Asia and other countries, including Europe and even Siberia. The period is considered the dawn of the human race, these people representing modern humans. We see the development of even more tools. The Neanderthal, who came from the same lineage as modern man, continues to decline rapidly in numbers. They are primarily cave-dwelling hunters and are short and powerful, 5'5", 175 pounds. Many bred with modern humans and were eventually outnumbered 10 to 1. They gradually fade out of the population. They are replaced by more intelligent offshoots, such as the Cro-Magnon man. There are many theories as to why Neanderthal eventually became extinct. By 40,000 years ago, there is no longer a species known exclusively as Neanderthal. 30,000 years ago to 15,000 years ago, more of our ancestors move into Europe and the Americas. We endure an ice age and develop more skills and intellect. We begin to see beyond the present survival and recognize distinctions between animals and humans. We begin to paint images in caves. Dogs were first domesticated in Central Asia by at least 15,000 years ago by people who engaged in hunting and gathering wild edible plants. The first successful domestication of plants, as well as goats, cattle, and other animals, occurred sometime around this period. It results in primitive farming-like communities. That is a critical time in our evolution. 15,000 years ago to 7,000 years ago, the ice age reverses. Sea levels rise. Lakes and rivers form. Plants and animals are plentiful. Farming begins and we are no longer nomadic people. We settle near rivers and the first signs of civilization emerge. Spread throughout the globe, we learn to plant seeds, grass, sugarcane, wheat, and barley. This becomes most of our calorie intake. Those with rich soil and a mixture of plants and animals have the advantage. Moving away from being nomadic to becoming farmers gives us more time to share ingenuity, skills, and the development of specialized trades. The first use of boats emerges in the form of canoes, reed boats, and rafts. Roughly 6 million people now inhabit the planet, and that is 7,000 years ago. 7,000 years ago to 4,000 BC. 7,000 BC to 4,000 BC, which is about 9,000 years ago to 6,000 years ago. The ice retreats back to the poles. The domestication of plants and animals causes centers to develop with large populations, innovation, and power. The cultivation of rice occurs in China, roughly 6,000 BC or 8,000 years ago. The continued development of agriculture is a watershed moment in humankind's evolution, changing the way we live and the way we interact with the world around us. So So we see this agriculture changing everything, the way we live, our ability to stay in one place, not be nomadic, and develop, be more inventive, and so on and so forth. The cultivation of barley and wheat used to make beer and soup is eventually used to make bread. Plants and animal species continue to coexist. Houses are made of mud brick and are built touching against each other. And we will end there, part 1. In part 2, we'll continue from there and look at 4000 BC, or 6,000 years ago, up to the present. Well, that's been great having you today here on Dr. Doctor. I hope that as maybe boring as that was, it was at least informative and educational. And I'm wishing you a great day and a great week. See you again in our next podcast.